Hello students. In this lesson we're going to find the area between two curves. The area is bounded by this cosine function here, which has an amplitude of 6, and the sine function, which has an amplitude of 4, and then has this frequency here too. So this is going to double the amount of oscillations within one period. And then this x is going to be in the first quadrant, so it's going to be between 0 and pi over 2. Now, there's one subtlety that comes up in the statement of this problem where I got this, and I'll clarify that in a moment. All right, so the let's give these a color. I'm going to make the 6 cosine, I'm going to make that red. So that's going to go down to, so that's a cosine. It's from 0, and then at pi over 2, it crosses the axes. And then the blue curve, I'm going to make a sine. And so that's going to be sine 2x. Now remember, the sine is normally 1 at pi over 2, but because of this doubling here, it's going to oscillate twice. So at pi over 2, if you plug pi over 2 in, 2 times pi over 2 is the same as pi, so sine of pi is 0, so that's one help. Now, normally we might think of the area between curves as this region here and this region here. However, and this is a subtlety I mentioned earlier, in the statement of this problem, from where I got this problem in the text, the authors just want the area of the green region. So that's what we'll compute. So we need to find this point of intersection. So we set the blue curve equal to the red curve. That's where they intersect. So 4 sine 2x is equal to 6 cosine x. And I'm going to expand sine 2x. So sine 2x is 2 sine x cosine x. And now we're just off to the races solving for that point of intersection before we set up the integral. So I broke off that piece. This is the only region we want. So what I'm going to do here is I'm going to take 4 times 2. That's going to give me an 8 sine x cosine x. I'm going to push the 6 cosine x over to the left-hand side. And then I'm going to factor out a cosine. And that'll leave us with an 8 sine x minus 6. And then 8 sine x minus 6 equals 0. Push the 6 over, divide by 8, you get 3/4. So x is the arcsine of 3/4. And cosine of x is equal to 0 when x is equal to pi over 2. But again, we're not going to compute the area of this region where x is pi over 2. That's what that's going. We're just going to compute the area of this region. So we'll get rid of all this stuff here. So we'll ignore that part. All right, so let's continue. So our limits of integration are going to be 0 to arcsine of 3/4. So the area between the curves, let's see, the top curve is the 6 cosine x. That's the red curve. And the bottom curve is the 4 sine 2x. So we'll subtract the top minus the bottom. And then again, we're integrating from 0 to arcsine of 3/4. So let's set up that integral. We did that up here. Now, if we integrate cosine, we get a sine. If we integrate sine, we get a minus cosine, and then we have a 2x in here. Now, you could do this by u substitution, or you could just realize that, like if you let u equal 2x, then du is equal to 2 dx, so 1/2 du. So you get a 1/2 factor out in front. Or you could just realize that if you differentiate cosine of 2x, you're going to get a minus, that's where the minus sign, you're going to get a sine of 2x, and then the chain rule is going to pop out, and you're going to get a 2, and that added factor 2. So to get rid of that factor 2, you multiply by 1/2. However you want to do it, that should be a straightforward integration problem. If you're doing area between curves, you should know how to handle integrations like this one, I would expect. So now that we've computed this integral and attained this antiderivative, we're going to plug in the arcsine of 3/4 and the 0. So let's see, minus 4 times minus 1/2 gives us a 2. Okay, we got that. Now I take the arcsine of 3/4 and I plug it into for x to the sine function, plus 2 cosine, and then 2, and then the angle here is inverse sine, or arcsine of 3/4. I use the shorthand notation to save myself some space. And then we plug the 0 in. So 6 sine 0 plus 2 cosine 0. And then we're going to need to compute this cosine of 2 arc sine 3/4. Because clearly sine of arc sine 3/4 is just 3/4. But this one's tricky. Now remember cosine, this is a double angle formula. You have a couple options. It's cosine squared theta minus sine squared theta, but you can also write that as 1 minus 2 sine squared theta. That's a trig identity. So if we plug in theta is inverse sine of 3/4, and you'll see now why I chose this form of the double angle formula. It's because the sine of the inverse sine of 3/4 will just give me a 3/4. And then this quantity, this sine is being squared. So this sine is being squared up here. And so then 1 minus 2 times, and then 3/4 squared is 9/16. So that's 1 minus 9/8. And then that's 8 over 8 minus 9 over 8 is minus 1/8. So whenever I see this cosine of 2 arc sine, I'm just going to stick in a minus 1/8. So so this is work we'd already completed. So 6 times, let's see, sine of arc sine of 3/4 would be 6 times 3/4. These are inverse functions. We already computed that the cosine of this 2 arc sine was minus 1/8. So 2 times minus 1/8. So that's this definite integral computed. 6, let's see, sine of 0 is 0. So 6 times 0 plus 2 times cosine of 0 is 1. So we'll have, let's see, 6 times 3/4 is 18 over 4, which is 9 over 2. Minus 2 times 1/8 is 2 over 8 is 1/4, so minus 1/4. And then that's a 0, and we get a minus 2. And so we just do a little fraction arithmetic. Let's put 4 as the common denominator. So it's 18 over 4 minus 1/4 minus 8 over 4. And that's 17 over 4 minus 8 over 4 is 9 over 4. And that's 2.25. And that should complete the problem. Good luck.